everyone, in this video we're going to be integrating 1 over 1 plus sine squared x dx. Now this problem was suggested by one of my viewers recently, and I really liked the problem, so I wanted to make a video, and I even got the hint for the solution. So thank you, user -LU6YG3VK9Z, for the suggestion. So we're going to go ahead and integrate this function, which is 1 over 1 plus sine squared x. Obviously, this problem can be solved in more than one way, so I'm going to go ahead and do the general method which was suggested, and then for the second method I'm just going to suggest an alternative, but probably not going to complete it because that'll probably take forever. Not forever, but it's going to take a long time. Hopefully you can do that as an exercise, right? Okay, great. So we have this integral 1 over 1 plus sine squared x, and here's what we're going to do. We're going to go ahead and take 1 over 1 plus sine squared x and manipulate it trigonometrically to turn it into something that is easier to handle. And that can be done by multiplying by secant squared, top and bottom. And you know why that works? Because sine squared multiplied by secant squared becomes sine squared divided by cosine squared, because secant is the reciprocal of cosine. So sine squared over cosine squared is going to be tangent squared, and guess what? The derivative of tangent is secant squared. So that's pretty convenient, right? So let's go ahead and do it. When we multiply secant squared by 1, that's just going to give us secant squared. And when we distribute the secant squared, we're going to get secant squared plus sine squared times secant squared, which I told you already is tangent squared. So this is basically what we get from that expression. Obviously, this is much, much better than 1 over 1 plus sine squared. Great. Now, let's go ahead and simplify this even more, because secant squared is 1 plus tangent squared. Hopefully you knew that. If you're integrating functions of secant and tangent, or powers of secant and tangent, by the way, I made videos on those, you can go ahead and check them out, but you want to know how to convert them to each other. So secant squared can be replaced with 1 plus tangent squared x. Make sense? Let's go ahead and do it and see what happens. So we're going to get the integral of secant squared x dx. You can also write this dx separately, doesn't matter, no big deal. But at the bottom, we're going to be getting 1 plus 2 times tangent squared x. Now this is what is cool about it. If you use a u substitution here, then this will turn into an easier integral. How does u substitution work? You try to find something, the u, and then you differentiate the u, and if you also see its derivative inside the integrand, which is such a weird word, but then you're good to go. Well, at least give it a try, right? So, but the choice of u is important. Sometimes we choose the whole thing, like this one. Sometimes we choose part of it. In this case, it will be convenient to choose tangent x. So, u equals tangent x, and then from here, du is going to be the derivative of tangent. Remember what I told you about the derivative of tangent? It's secant squared x, and of course don't forget to multiply by dx. So that gave you the numerator, notice that. And at the bottom you have 2u squared plus 1. 2u or not 2u? Well, if it's your birthday, happy birthday to you. Okay. So this gives us the following then. du divided by 1 plus 2u squared. Fairly simple, right? Well, this comes from a trigonometric integral, but now we're going to use trigonometry one more time. That's what's really cool about this. And again, I thank you for the suggestion. This is a great problem. If you have any other problems like this, please let me know. I'll be more than happy to make a video. But anyways, here's what we're going to do. Whenever you have something like 1 plus u squared or some number plus u squared, and you prefer to have a perfect square, of course, a tangent substitution would be helpful. In this case, the first scenario, u would be replaced with tangent theta. In the second scenario, you would use a times tangent theta. So the goal is to get 1 plus tangent squared inside the parentheses, which can be turned into secant squared. Does that make sense? So here's what I'm talking about. In plain terms, I want you guys to replace u with something. But wait a minute. The coefficient of u squared isn't 1. What can we do? Easy. You can just take out a 1/2, and that'll do the trick. Now you have du divided by 1/2 plus u squared. Oh, you always want to have a single u squared, but there are formulas that will give you, some u squared plus some other number, whatever. I don't like it. I don't want you to memorize all these formulas. But here, our a squared is just 1/2, so we kind of have like 1/2 root 2 squared plus u squared. So here's what we're going to do. U is going to be 1/2, 1 over square root of 2 times tangent theta. Make sense? When I square this, I'm going to get 1/2 tangent squared, which is going to go along well with the other guy. And from here, du is going to be 1/2 tangent squared. What am I talking about? I'm kind of confusing myself here. Okay, du is going to be 1/√2. The derivative of tangent is secant squared theta d theta. And of course, 1/2 plus u squared is going to be 1/2 plus 1/2 tangent squared theta. And this is going to become 1/2 times 1 plus tangent squared theta. Yes, this is what I was talking about. And this is secant squared, as you hopefully know. Great. So I got everything I need. I got the du, I got the u, and I don't really need u. I just need 1/2 plus u squared. So let's go ahead and make the substitutions here, right here, 1/2. What is du? Du is 1/√2 secant squared theta d theta. And at the bottom, I have 1/2 plus u squared, which was simplified as 1/2 secant squared. Do you see that? This is equivalent to that. Awesome. 1/2 secant squared. Of course, there is no d theta at the bottom, right? That would be ridiculous. Wait a minute. Can you integrate 1/d theta? That would be an interesting problem. Anyways, let's not get distracted. Secant squared cancels out. Wow, that's amazing, isn't it? We end up with a number, but guess what? 1/2 also cancels out. Such a weird cancellation. And we end up with 1/√2. Let's clean this area. Hopefully you got a picture, right? If not, please go ahead and take a picture. Now I'm going to go ahead and erase this. Ready, set, go. All right. And now we're going to go ahead and finish this up. And this is going to be a very, very simple integral to do, because now I have 1/√2 times d theta. Come on. You should know how to integrate d theta because it's just theta. But don't forget the constant. Otherwise, you'll lose points and I'll be sad. So that's the answer. But what is theta? Wait a minute. What is theta? Where does that come from? Okay. Let's think about it, right? Where does the theta come from? Go back to basics. Uh-oh. Where did I make the replacements? I totally forgot, right? But here's the thing. Theta was actually u was 1/2 tangent theta, right? 1/√2, I'm sorry. Let's not forget it, because when we square, we're supposed to get 1/2, right? So tangent theta is going to be √2u, okay? And then theta from here is just going to be tan inverse √2u. And obviously, some people are going to write this as arctangent, which is fine. Some people write arctan. Some people write tan inverse. In the United States, they use the tan inverse notation. And since the majority of the viewers are from the United States, anyways, that's a different story. But this is what it is. But u is 1/2 of tangent theta. So what is u? I kind of have to go back to u is tangent x. Great. So now I'm going to go ahead and replace u with tangent x, right? And that's going to give me theta equals arctan. Okay, I'm going to use that notation. √2 times tangent x. So my integral is going to be then 1/√2 times theta, which I'm going to be a little lazy here. I'm going to go ahead and take this expression, move over here, and guess what? That's going to be the answer. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.